The first step to solve this problem is again to determine which equation we want to use. And because this problem here tells us that interest is compounded monthly, we are using this equation here because it is compounded a certain number of times per year. So we're now going to use this chart here to figure out what these values are that we need to substitute into our equation. So we are told that Craig wants to have $12,000 in his account after 7 years. So this $12,000 is our ending value. This is the amount of money that we want to have in our account after 12 years. So it is our A value. The value that we are looking for, that we want to solve for, is this P value, because we want to know how much money Craig needs to invest now, how much this initial value should be in order to have $12,000 after 7 years. So that brings us to our time, 7 years. That means our T value is 7. We're told that there is an 8.75% interest rate annually, so our R value here is 0.0875. Always remember to change our percentage into a decimal. And finally, N tells us the number of periods in each time period, the number of times we are compounding. We are told that the interest is compounded monthly, so our N value is 12. Now that we've figured out each of our variables, we can substitute these values into our equation here and solve for P of 0. So we have 12,000 is equal to P times 1 plus 0.0875 over 12. And we're taking that to the power of N times T, which is 12 times 7. And this is very squished. We have 12 times 7 up here. So when we simplify this, we get 12,000 is equal to P times 1.00729 to the 84th power. And finally, we're going to simplify this one more time. We get 12,000 equals P times 1.8407. Then we divide both sides by 1.8407 and we get P is equal to about $6,519. So this problem tells us that Craig needs to invest around $6,519 today if he wants to have $12,000 in his account in 7 years.